moving on, let's just clear some space. Something new is coming in. It says 3.3 from the top of a perpendicular cliff AB. So there is a cliff, you see, from AB, from that top cliff AB, which is 50 meters above sea level. The angle of depression of two points C and D in the same plane at 25 and 30 degrees respectively. So they are saying if you want to look at D down there, there is D down there, the angle for you to look at D is 30 degrees, and the angle for you to look at C is 25 degrees, the angle of depression. So what are they saying? They're saying calculate the distance of the boat D from the foot of the cliff. Calculate the distance of the boat D from the foot of the cliff. So they want you to find this distance, which is AD, from here to there. Are you with me? Again, look at the shape of the triangle that is formed here by that. Look at this. It's still trig ratios. So now what is interesting is, what is that angle? Now you need to know, I'm going to do it with another marker. You need to know the total angle. See, here it's a 90 degrees. This is a 90 degrees. So now I know that this is 30. Now the question is, what is that? So it's simple. 90 minus 30, which is what? Which is this is 6. You see, this is 60 degrees. Why? Because if I say 60 degrees plus 30, I'll get 90. Then if I'm to find this angle AD, we can call it X, whatever. It's about trig ratios. You ask yourself, what line? Okay, now remember I have a 90 degrees here, and I told you there is a special thing that happens when you've got an angle and a 90 degrees. There's a special side here. We call this side the adjacent, right? So we have the adjacent, and then at the same time with the adjacent we have also the angle. And what is this side called? This side is called AD is called the opposite. Why? Because the longer side BD is called the hypotenuse. So you ask yourself, on the trig ratios SO, CA, TOIA, which one works? We have got the adjacent. So you see, there is the adjacent and there is the adjacent. So forget about sine. It doesn't have adjacent. And then we're looking for the opposite. There is the opposite. So they've got two. So this is out. So we go for 10. 10 theta is equal to opposite over adjacent. That you need to know. These trig ratios are very important. And then some of you are going to come and say, but this is confusing, and where do you get it from? Let's go to the formulas for a bit. Now, when you look at these formulas here, as I said, let's go through these formulas. And I think this is the only formulas. Unfortunately here I don't see any trig ratios, which is fine. They didn't bring any trig ratios, but they say they are, which means they expect you to know. Now when you look at this trig ratio, unfortunately it's not in your formulas. It says 10 theta is opposite of adjacent, but it's expected that you know. Now what is your opposite, and what is your theta, and what is your adjacent? So you say 10, the angle there, theta, is that 60 degrees, is equal to the opposite is what we want, which is our AD, over the adjacent is that AB, which is what? Which is 50. See that? Then, like we did previously, how do we find AD? You multiply this time side by 50, but what you do on the left, you also do on the right. You also multiply by 50. That's how you get rid of that 50. Then you are going to say AD is equal to, that's when you say 50 times 1060. You see, that is how you will get now the answer, to say 50 times 1060. It gives you what? 50 root 3, which is 86,6025. 3 decimal place 603. So shift setup 6 in 3 decimal places, which is 86,603. So you have got 86,603, but we're talking about distance here, which is in meters. Are you with me? So that is how you find that distance. And then the next one says calculate the distance between the two boats. Okay, we're fine here. I'll put that distance in remembrance to say this is equal to 86,603. Now they want the distance between the two poles, so they want this distance. I'll make it a bit thicker. They want DC. I mean distance. There is a distance from D to C. That is the distance between the two poles. That's what they want. But what do you do again? You come here. Let me erase this part. Let me erase this part, because let me erase actually all this, so that I can show you how they trick you in a way when it comes to this kind of equation. Okay, let me not remove my trig ratios. Let's maintain the trig ratios. I did write that 86.603. But now look at this. This code that I know distance AB. Now what if I want to find distance AC? If I find distance AC is good, I can subtract AD minus AC. It will give me DC. You see, so I want this distance now from here A to C. Now the triangle I'm going to use is this one. I need to look at the triangle I'm going to use. This is the triangle I'm going to use. But if I'm going to use that triangle, again, I still have my 90 degrees. That is fine. But I want this angle. If you still remember, we said this was 60 degrees previously. 60 degrees previously. Now the question is, what is this small angle? Now, if from here is 25 and from here is 30, you can see that this small one becomes 5 degrees. Why? 5 plus 25 give me that whole 30. So which means the distance of this whole angle is 65 degrees. So I've got that distance. I still have my adjacent side, this one. So the question is now, I want to find AC. Obviously AC must be bigger than 86,603. And what am I going to use? You come back to your trig ratios again. Nothing has changed. It's still the trig ratios, and it's still 10. Why? Because you're still using the same adjacent side. So you're going to use 10 theta, which is now 1065, say, is equal to opposite, which is what I want now, as AC, over adjacent is still 50. See that? Then how do I get rid of that? Multiply by 50 here, multiply by 50 there. Then it will give me my AC, which is 50 times 1065. As I say, it must be a bigger size. 50 times 1065. What does it give me? Equal to, it gives me, you see, it's bigger number, 107,225. 107,225. It's what? It's meters. So that is the whole distance here, which is 107,225. Now the question is, I just want this portion now. I just want this portion here, from here to here. You see? So from here to here, I subtract. So you're going to say distance between the two poles, which is DC, is equal to 107,225, which is from what? AB. So in a way, that distance is DC. Let me write it on top here. DC is equal to AC minus AD. So which is that? Minus 86,603. Then it will give you now that particular distance. Are you seeing? And then if I can just subtract that, it's 107,225 minus 86,603. What does it give me? It gives me 20,622. So that is that distance, guys. 20,622 meters. So the distance between the two poles is that. As I say, it's revision time. I will teach this as I'm starting now to have a look at NCV, and guys, I will be your tutor for NCV. I don't want you to struggle at all. So in as much as it became tough for you in your level 2, let's say you passed it, and I'm hoping that you pass it. Let's do level 3 together. Okay, if you're joining me for the first time in your level 2, we're in here for a long journey, but an interesting one. Okay, Now let's look at the graphs. 3.4. 3.4.1 says draw the graph of f of x is that and g of x is that on the same system of axes where theta is less than or equal to 0, x is less than 0 to 360 on the addendum attached. First complete the table of values of f of x and g of x to help you draw the graph. It's 6 marks, guys. Come here to see what they attached. Look at this. When I'm going to be drawing, it's not the one. I don't think this is the one. There we go. Look at this. They want you to draw this graph, and the good thing is they made it simpler for you. They even gave you this. Look at this. They gave you what to fill in. But now this is all that, is your calculator here. Just rely on the calculator. Look what I'm going to do. I get my calculator. Unfortunately, my calculator can't do 2 graphs at the same time, but yours can do. Just play around it, you'll see what I mean. So what you do, first you say mode, you say table 3. F of x. Mine only has f of x. Yours will have g of x. It will allow you to have 2 graphs at the same time. So I'll say f of x is equal to 2, and then I say sine. Then how do I put that x? You say alpha x. See that? You close, and then you say plus 1. You see, if I say equal to, your calculator will say g of x. So you say g of x is equal to, you do again 2 sine alpha x. You close. You understand what I'm saying? Then equal to, then you need to say start. Where do you start? It says I must start from 0. You see, x must be 0, equal to, and then end. I must end in 360. You say 360. Every time you punch, you say equal to. Steps. Look at the steps they are saying. 0, 30, 60, 90, 120. So the steps are steps of 30. So equal to. Then you have now in your side, you'll have x, f of x, and g of x here. Those are the values you want. So now, how do I now fill in? Because I'm doing the first one, I'll do the other one. But check your calculator well. 0 is 1. 30 is 2. Do you see what's happening? 0, I must put, when x is 0, I'll put a 1 there. When x is 30, I'll put a 2 there. So let's do that. 0 is 1. 30 is 2. So I continue doing that. Go down. 60 is what? 60 is 2,73. 90 is 3. 2,73 and 3. 2,73 and 3. Continue. And then 120 is 2,73. 150 is 2. 2,73. 150 is 2. Continue. You see, I'm going down. 180 is 1. 210 is 0. I continue. 240 is negative 0,73 and 270 negative 1. So negative 0,73 and negative 1. Continue. And I go to 300. 300 is negative 0,73. 330 is 0. I think they made an error. They say 300, but here it was supposed to be 330, which is 0. And then 360 is 1. That's the end. You see, there is nothing further here. It's the end. 360 is 1. So that's it. So you are able to actually do f of x and g of x at the same time. Now, since I've done f of x, I have to do the same thing for g of x. So this is what I do. Still on the same, still on f of x. So, but I'm now doing g of x. But because it can only allow one graph at a time, so that's why I'm doing it again. 2 sine alpha x. Where is my x? X is somewhere here. And then you close the bracket, equal to. You remember we're starting from 0. It still keeps that. We're ending in 360. It still has that. The step is 30. It still have that. Now I do the same thing. 0 is 0, 30 is 1. So 0 is 0, 30 is 1. Continue. And then 60 is 1,73, 90 is 2. 60 is 1,73, 90 is 2. And then 120, 1,73, 150 is 1. Continue. 180 is 0, 210 is negative 1. Continue. And 240 is negative 1,73, 270 is negative 2. Continue. 300 is negative 1,73, 330 is negative 1, and 360 is 0. So negative 1,73, negative 1 is 0. Alright, so this is actually you saw what I did. I didn't even use my knowledge. I just entered this in the calculator. It gave me these values. Then I have to plot them. They even gave you the graph, the good part. Now I'm going to use red for the first graph, and then I'm going to use blue for the other one. I wish I had already used blue on the other one, just not to confuse, you see. So if I can just apply my blue here, 0, 1, 1,73, you can continue all the way, you see, just to make it different. But in your book also, you have to use one pen. If it's black, it's black on both. This is blue, is blue. All right, look at this. Let's start with the first one in red. The first one is what? I'm saying when x is 0, f of x is 1. These are the y-axis. So if it's 0 here, f of x is 1. There is a point there. You see what I'm doing? Let me make it bigger now. This is the point there. When is for 30 is what? 2. Then there is another point there. For 60 and 2,73, just ignore that. I know it's there to confuse. You want to plot 2,73, but leave it out. Go for 90. Look at 90. What do you have? For 90, you have 3. Focus on the numbers that you can easily see. And then 270 again, 2,73, leave it out. Then go for 150. What is 150? 150 is 2. Focus on what is clear to mark. And then 180 becomes 1. It's easy for me to mark that one, you see. I'm looking at the one that I can simple mark. 210. What is 210? It's 0. So I do that. Are you seeing that? And then 240, complicated. 270 is negative 1. I got there. So we continue. And 300, let's leave it out. 330, we say it was 0. So let's look at, it was what? 3, yeah, it was negative 1 is 270. 300 was that, but 330 was 0. So let's just go there and have my 0 there. And 360 is positive 1. See? It's there. Alright. So that is what we are having on the first one. Now if you say I must draw that, it's not a difficult graph. You can see it actually shaping. This is a sine graph. You must have practiced with this kind of graphs. Okay, it's like I'm not doing the right one there. Let me do it again. You just need a smooth kind of a graph that you need to draw in this case. So I have something like this. This I hope will give me a smooth line. You know, but when you're drawing it turns that. So you need to label because they'll penalize you if you don't. So you're going to say this graph is what? F of x is equal to what? You need to label it in full. What is that f of x? It is equal to 2 sine x plus 1. Then the other graph we are now plotting is the second one, g of x. I'm going to use a different marker now. Now we do the same thing because we need to see the values. When x is 0, that graph says what? When x when x is 0, the graph is also 0. I have a point there. Are you with me? I'm marking there. When x is 30, I've got 1. When x is 60, complicated, but when x is 90, I've got 2. Just be careful that you're now looking at g of x. Remember the blue one. When x is 120, 1,73, leave it out. When x is 150, I've got 1. When x is 180, I've got 0. When x is 210, I've got -1. When x is 240, leave it out. When x is 270, I've got -2. That's 270 is -2. So I come here for -2. I need that point here. And then check again. When x is 300, leave it out. When x is 330 is -1. 330 is -1. And then when x is what? When x is 360 is 0. These are the points. Now you need a graph also. It's similar. We are dealing with sine and sine, so it must take the same shape here. But now you need to have a smooth graph. Now this is the graph. It goes like that. You need to have practiced with these graphs. Okay. So I needed though to go through the actual lines. I don't like it when it actually doesn't go through the lines. I must touch the lines. See what I mean? I must touch the lines like this. Okay, so now when I've drawn these graphs like that, what is the question saying? So these are the graphs, they give you 6 marks. They will want this completed. They will want the shape. Oh, you know what I did? I didn't label this one. This graph is what? Let me use a smaller part. What is this graph? This graph is called g of x is equal to what? 2 sine x. They mark that. So don't be fooled and leave it out. Even also that saying this is supposed to be x and that is supposed to be y. It's standard. You need to do that. Okay. So now I hope this is what was needed. Now let's look at the question they want in this kind of a question. It says draw the graph of blah blah blah. What is the amplitude of f of x is equal to 2 sine x plus 1. The amplitude means the highest point of that graph. So you come here and say the highest point of f of x, the amplitude. Now you mustn't be tempted to say it's 3. You see the highest point goes here. Let me show you this. There is a highest point here, but that's not how you use that as 3. So what you do is you look where the graph is having a central point. Start from that and that. That's a very important line. Then the amplitude is that distance there. You understand what I'm saying? Or that distance there. Provided you have got the middle division line. And then on the other one, our middle division line should have been this one. See that? And our amplitude was going to be the other one there. I don't want to confuse you with the other one because the line will still be on the same one as that. So let me leave it out for now. So amplitude, find the central point of the graph. We call it where the displacement is 0, like the actual point from 0 to the next 0. That is where the graph is turning into, you see, so that you can now know the amplitude. So the amplitude of this graph is from here, it's 1 and 2. You got 2 steps. So the amplitude there is 2. Are you seeing that? That is the answer that they wanted. So here when they ask you of the amplitude actually is that number. So you can actually find it without the graph, which is equal to 2. What is the range of f of x is equal to that. Now, when they are asking about the range, remember we have got domain. Domain means what? Domain is equal to x values. And then range is equal to what? Y values. So when they gave you this graph, they gave you the domain, they gave you the x values. Now they're asking you for these x values, what are the values of y that are possible? So you come back to the graph here, is 2 marks. you come back to this graph and say for f of x, you see the y values, we're talking about these y values. You can see that y can go all the way from -1. It goes all the way from -1. It goes up to there, to -3. It stops. It starts going down all the way. These are the y values. It starts going down all the way to -1 there. Are you seeing that? Then it goes there to -1. So that is what they are talking about, that distance where the y values are possible. So the range here, when you're going to say the range, you are going to tell us about the possible values of y. You're going to say y will start from -1 is less than or equal to y. Y is less than or equal to, it goes up to 3. This is the range. You can split it into 2 to say y is greater than or equal to -1 because it goes up. But y, at the same time, you're going to say y is less than or equal to 3 because it does not pass 3. Are you with me? Or some they prefer like this, to say y is an element of real numbers. Okay, not real numbers here. They say y is an element of, you put that to say -1 up to 3. And then when you put square bracket, means 3 and -1 are included. Yes, that's another one. But where y is an element of real numbers, but within that range. But the best one is just that top one here. This is the best one. This one is the best one. So guys, how many marks does this give you? I hope it was making sense. It just gives you 28 marks, 28 good marks that you can score in that. So guys, it might have been a long video now. I have to split it into 2. So what I'll do is I'm going to split it in such a way that you're going to look at the first question, like question 3.1, and I'll give you 3.2, right? After giving you 3.2, if I cut it now, then I'll give you 3.3 as well as 3.4. So look at the 2 videos. They are going to be split into 2, 3.1 to 3.2 as one video, 3.3 and 3.4. So now we've come to the end of our lesson. Remember guys, it is important that you are subscribed. If you follow me, I'm going to be with you in this journey of NCV, and I want you to realize your dream. I want you to be the artisan you want, to be the engineer you want, but let's work together. Mathematics is very, very important aspect of it. If you struggle with maths, it can stop you from realizing that dream. So give me a comment, share the channel as much as you can, tell your friends and everybody. It gives me more motivation to bring you these videos. We've come to the end of our lesson. Thank you.